Hello there, this is Ms. Nakayama, and today's lesson is 4.4a, Factoring Polynomials. You know most of these already. This is just going to give you an overview so that you can hopefully tackle any kind of factoring problem. So let's quickly go over these, do a few examples so that you can get on your way. All right, when you are factoring, the main thing you want to do for any type of factoring from now on is you want to look at, no matter how many number of terms that you have, I'm going to group all these by the number of terms. No matter how many you have, the first thing you should always do is look for the greatest common factor, also known as the GCF. So any time, that's the first thing we want to do. Now, next, when you look at the number of terms, if you have two terms, you have what we've already talked about before, the difference of two perfect squares. I often refer to that as a D2S, and you can't read that at all, so I'm going to go use something else here. D2S, okay? A squared minus B squared right here. A squared minus B squared is A plus B times A minus B. Those are called conjugates of each other, okay? We have a new one today. This would be something that's new that you haven't seen before. It does have a pattern. That would be the sum and difference of two cubes. So if you look at this pattern here, this is A cubed plus B cubed. You take the cube root of each of those, that gives you A plus B. Then, using your A plus B, you're going to square the first one, change the sign, multiply them together, and square the last one. So the only difference in this one and that one is the sign of this term right here. So there is a mnemonic that we use to remember, and that is called SOAP. This is, didn't change back, sorry. Okay, this sign is the same sign as the original problem. This sign is the opposite, and this one is always positive, because as we've said, when you square a number, it's always positive. So that's what this SOAP, if you ever hear me refer to it. So this is different than what we did last time, which was cube a binomial. That was more along this right here. This is when you look at the beginning. Now, difference of two squares, y'all. I have squares and I'm subtracting. When you have cubes, you got to keep in mind that you can have A cubed plus B cubed or A cubed minus B cubed. I'm going to do some examples. This is a pattern. This guy right here, this second factor, is always prime. It cannot ever be factored. So, not necessarily a hard thing to do, but you've got to memorize this pattern. Okay, so that is starting off with two terms. If we start off with three terms, okay, then we have something that I have talked a lot about with you this year, and that's called a perfect square trinomial. Okay, and our perfect square trinomial, I'll come back to that. A squared plus 2ab plus b squared equals a plus b quantity squared. The only difference in these two expressions is that, and I've said to you many times, whatever this sign is the sign of the second term. So you get something from every term to create this. And what I want y'all to see, I want you to notice that when it is short, okay, this is start off with short and you have to factor, it becomes something long. When you start off with something long and you start to factoring, it becomes something short. I'm trying to help you distinguish between something like this and something like that, because people get confused with them all the time. Okay, our general trinomials in this next group here, general trinomials, use whatever factoring method you want. This is showing examples something like a factor by grouping, but it's really whatever factor we've done this before, you've talked about, so just be familiar with it and know how to do it. And last but not least, we can have four or more terms, and that you will do grouping. And I'll talk a little bit about that in our later in the video. The trinomials, what I spent most of our time this year was doing guess and check, but some people do other things. Okay, so here are our examples. Finding a common monomial factor. So when you look at A, I've got x cubed minus 4x squared minus 5x. You're looking at the numbers and you're looking at the variables. There's no common number, no common factor that's numeric, but there is a common variable of x. So I'm going to take x out of everything. And one of the things to remember, y'all, is if I have 3 terms to start with and I take out a common factor, I have to have 3 terms inside. So, sorry, don't know why it does that. So, I'm going to take an x, and it's kind of like you're taking each one. I've done this before a lot. Take each one, put it over x, put it over x. And what are you left with? X squared minus 4x minus 5. And we are stepping up the game. We are no longer in Algebra 1, we are in Algebra 2. So whenever you take out a common factor, you always have to check and see if it can go further. Can I factor this guy any further? Absolutely. That's what we just did when we spent time doing our trinomials. I'm looking for the factors of 5 that subtract to give me 4. So I'm going to have my x, and then I'm going to have the answer. I'm going to have x. The factors of 5 are only 1 and 5, and I just got to figure out which one's negative. And when that's the case, the larger number is going to be the same sign as that middle term. So it's going to be x minus 5 and x plus 1. This is not the point of the video, so I'm not going to spend a lot of time doing that. I'm talking about multi-step factoring now. All right, B, 3y to the 5th minus 48y cubed. This time I have a 3 that goes into both, and I have a y in both terms. And when you have that, you're taking the smaller exponent. That's what's in both of them. So in this case, that is 3y cubed. Again, I start with 2 terms. I'm going to end with 2 terms in my parentheses. When I take a 3y cubed out of this right here, I am left with y squared. And 48 divided by 3 is 16, and the y cubes are gone, so that's minus 16. Again, after you do a GCF, you always got to look and see if you can go further. Y squared is, of course, y minus 4 and y plus 4, because that's the difference of 2 squares. This is a perfect square, that's a perfect square. That's the difference of 2 perfect squares. C is 5z to the 4th plus 30z cubed plus 45z squared. So I have a 5 and everything, and I have a z squared. You always take the smallest exponent. So my 5z squared is going to leave me with 3 terms inside. That's going to be z squared plus 5 times 6z plus 5 times 9. Okay? Now, that's a trinomial. I got to check and see if it can be factored. And when you factor a lot of things, y'all, and you really have to do this trial and error method, you start looking for the shortcuts. And the shortcuts are, that's a perfect square, that's a perfect square. So I'm going to think maybe this is a PST. So it's going to become 5z squared times z plus 3 quantity squared. Okay? Z times 3 is 3z times 2 is 6z. That's my middle term. Again, easier than a guess and check. All right, factoring the sum and difference of 2 cubes. Sum or difference. Okay, when they're squares, right here, can only be minus. But if it's cubes, then it can be a plus or a minus. So, a couple things. One, let's talk about what our factoring pattern was. We had it up top. We've got a cubed plus b cubed, and that is equal to, I've got 2 parts to it. You take the cube root of each, a plus b. The cube root of a cubed is a, cube root of b cubed is b. So I'm going to have a plus b, and then as I said before, you square the first term, a squared. I'm working with this factor. After I take the cube root of this, I create a factor, and then I'm working from this factor to create the rest of it. So I square the first term, change the sign, multiply them together. Come back on that 1 second, y'all. Change the sign, multiply them together, and then it's always positive when I square the last term. So when you saw that blue in there, that's because if there's a minus here, then there's a plus there because they changed the sign. That would be if it's minus. So that's the only difference. You really only have to learn one pattern. And as I mentioned up top, this second one is always prime. So you do not have to factor it. So you don't need to spin your wheels trying to guess and check. All right, let's review our cubes real quick so you can be familiar with those. The first one, of course, is 1. 2 cubed is 8. 3 cubed, 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So if you do not know those, you should be writing them down so you can be familiar when you see them. So when you look at this, you're going to go, oh, 125, that's in my list. I know that's a perfect cube. So I'm just going to use the pattern, okay? Not a lot of work to show y'all. So the first thing I do is take the cube root of each term, and I keep the sign the same. So that's going to give me x minus 5. X minus 5. So I'm going to square the first term, x squared. Change the sign, plus. Multiply them together, 5x, always positive, square the last term. And that's all it is. Now, when you look at this one, I got 2 terms. And of course, the first thing you're supposed to do is look for GCF. And I do have a GCF. My GCF here is 2s squared. So, for b, where'd my b go? I have a 2s squared, and after I take that out, I'm going to have 2 terms inside, and that's going to leave me with 8s cubed plus 27. Okay? Again, got to recognize those cubes. If you don't recognize those cubes, you don't know what to do from here. Okay? It is cubes. Cubes can be factored whether they're a sum or a difference. So I have to carry down my 2s squared. And then I'm going to have 2 sets of parentheses, and I'm going to take the cube root of each of these. The cube root of 8s cubed is 2s, same sign. Cube root of 27 is 3. Then I'm going to take 2s and square it and get 4s squared. Change the sign, multiply them together, 6s, and square the last one, plus 9. That's all it is. Again, recognizing those patterns is a lot easier. Okay, 2 more examples. First, factor by grouping. So when you factor by grouping, all that you're going to see this year with us is to group your 4 terms in 2 sets of 2. Okay? And when you group them in 2 sets of 2, you're looking for a common factor in each group. So in the first group, my common factor is z squared. And what's left is z cubed divided by z squared is z plus 5. Then you always, always, always copy that sign down, no matter what it is. It'll take care of things. What is the common factor between 4z and 20? It is 4. Now, when you do this, y'all, I can say this so I'm blue in the face, but if this is not exactly like that, you've done it incorrectly. So I encourage you to copy it, z plus 5. So I'm going to put z plus 5. Check it. Negative 4 times z is negative 4z. Negative 4 times 5 is negative 20. So I know that I have factored that correctly. Because if these 2 things are not the same, as I keep saying, okay, if they're not the same, you can't go any further. And I actually want to highlight it. This right here now is my common factor. So when I take that out, poo, go away. When I take that out, I have z plus 5. And what is left, when I take z plus 5 out of this first part, I'm left with z squared. And when I take it out of the second part, I'm left with minus 4. And again, not ever finish. You always have to look at your factors to see if you can go further. So I hope y'all recognize that is a difference of 2 squares, z squared minus 4. So that's going to give me z plus 5, and then z plus minus 2, z plus 2. The order of those 2 does not matter. Okay? Last but not least, factoring polynomials in quadratic form. Okay, quadratic form means they're not actually a quadratic, but they look like a quadratic. For example, okay, 16x to the 4th minus 81. That is 2 terms, which we call is the difference of 2 squares. it is the difference of two squares, because whenever an exponent has whenever a variable has an even exponent, it's a perfect square. So in part A, I'm going to take the square root of each term, and I'm going to get, what's the square root of 16x to the fourth? Square root of 16 is 4. The square root of x to the fourth is x squared. It's just half of it. So I've got 4x squared in beginning of both, and the square root of 81 is 9, and one of them is minus and one of them is plus. Okay? The key here, can I go further? Well, two terms that are perfect squares that are plus, always prime. Two terms that are perfect squares with a minus, that is the difference of two squares. So this one can go further, this one cannot. So when I factor the first one, I'm going to get 2x minus 3, 2x plus 3. I have to carry down my 4x squared plus 9, and that is how it factors. All right, let's finish up with B. Can be a little challenging. If you need some more help with that, I'm happy to do some more later. All right, 3p to the 8th plus 15p to the 5th plus 18p squared. Looking always first for a GCF, I got 3p squared. 3p squared is my GCF. That's going to leave me with p to the 4th. Nope, 6, because it's 8 minus 2. Good thing I wasn't taking the square root. P to the 6th plus 5p to the 3rd plus 18. Plus 6. Sorry, I was thinking about y'all questioning me. Okay, so when you take it out, 8 minus 2 is 6. 15 minus 2 is 3, and I've got squareds here. 18 divided by 3 is 6. So that's my GCF. Can this be factored further? So this is what we call quadratic-like. And the reason it is quadratic-like, okay, this quadratic form, because the exponent of p to the 3rd times 2 is p to the 6th. If you think of our quadratics, the first term is p squared, and that would be p. The point of it is if this one right here times 2 equals that one, it is quadratic-like. So when you factor it, just think about it like you were factoring a quadratic. I'm going to carry down my 3p squared, and p to the 6th, okay? Remember, if this was p squared and that was p, then I would have p and p. So now I'm just going to put p cubed and p cubed. I'm looking for the factors of 6 that add up to 5, so that's plus 3 and plus 2. And those are cubes, but 2 and 3 are not perfect cubes, so this is as far as I can go, and I did not mean to do that. And that's all we have for factoring. Y'all, there's a lot of practice for you because it's really, really important, and I want you to do well on your quiz. So I hope you will put some good effort into that and get a lot out of it. Thank you so much for watching, and I hope y'all have a great day.